Alrighty, in this lesson here, we will be talking about 9.6, which is vectors in the Cartesian plane. All right, the notes pretty much throughout this lesson is talking about the vector properties. So in our vector properties, we have some things to kind of clear up um, so that you're able to do the work relatively easy. And then we'll go over, of course, some of the homework questions through the practice in the textbook. All right, so you have vector properties for addition. In addition, two vectors added together does not matter the order that you add them. So if I do vector u plus vector v, it will equal vector v plus vector u. So it is a commutative property here for addition. It is also associative in the sense that I can actually add vector v plus w first, then add u, and that would be the same thing if I was to add vector u plus v and then add vector w. That would be the same thing. So it's commutative and associative. Also, if I add vector 0, I would just get right back to my original vector. And then if I add the opposite vector, I will get the vector 0. And just so you're aware, vector 0, or technically they call it vector O, is the origin point. So 0, 0. That would be what that vector is. We also have a scalar multiplication property. And it just basically means if I have a scalar A, so a non-vector, just a regular number, and I multiply it to a vector u plus v, I can actually apply it to both vectors and then add it. So I can either add the vectors, then multiply by the scalar multiple, or I can take the scalar multiple and multiply to each vector and then add those two corresponding vectors up. It can go in both directions, so I can actually write it like this as well. And it gives me the same outcome. Oh, my bad. Sorry, different direction there. If A plus B, these are both scalars, so regular old numbers, and then I multiply to the scalar U, that would give me the same thing as the AU plus BU. Meaning I can add up the two scalars, then multiply by U, or I can apply the scalar each to the vector, so AU, then BU, and then add those two vectors up, and I'll get the same outcome. We also see it works also with multiplication. So if I have two scalars A, B, and then I have a vector, so if I have two vectors being, or two scalars being multiplied to a vector, I can either multiply the scalars up, then apply it to the vector, or I could um, multiply the scalar B to it and then multiply the scalar A, or I can multiply the scalar A, then multiply scalar B. All three of these would equal the same thing. If I was to take the scalar 1 times the vector, I would just get the original vector. If I take the scalar 0 to the vector, I would get the origin, the O here, so little o. So this will take it back to the origin. And then same concept, if I take a scalar times the origin, I just get the origin as my outcome. If I take the what we call the magnitude or the distance of my vector, I can either have the scalar inside it, or I can pull it out as the absolute value of that scalar times the magnitude of the vector itself. So I can either multiply it first, then find the magnitude, or I can find the magnitude, then multiply it by a scalar. Both ways will get you the same thing. So basically, if u, the vector u, is labeled as u1, comma u2, and v is labeled as V1, comma V2. This is called component form when you have the inequality form, inequality symbols. Remember, component form. So if I was to take U plus V, I would just simply add their corresponding values. So this would be U1 plus V1, and then U2 plus V2. Same thing with multiplication of a vector. This would just be AV1, AV2. And then that last thing, that magnitude, if you want to find the magnitude of a vector, which is the distance, you just take the square root of the first number squared plus the second number squared. And that's pretty much everything that's inside the lesson. And then, of course, I want to go over specific examples to help you out. So let's start off with number one. Number one just simply says, use the figure to sketch a graph for the specified vector. So this is how you graph. So you're given negative u, and then it gives you a graph. So here's your graph here. Looks like u's at -1, -2. So this is my u. So I'm going to write over here. U then must be vector -1, -2. So if I want the opposite of that, I would literally just apply the negative to said vector. And when I do this, I would just get 1, comma 2. So to graph that, I now have negative u. Let's look at another one with the same graph. So let's look at number 3, and this one is 3v. So I see that v here looks to be at 3, -3. So here's v. So again, v looks to be at 3, -3. And then I need to do 3v. So that means that I'm going to do 3 times 3, -3. So this is my scalar multiple. When I multiply it in, I just get 9, -9. So real quickly, in a simplest form, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Probably not to best scale, but now this was considered 3v, which will be tripled the value of, or the tripled the vector of regular v. All right, so that's pretty much all you have to do on the first couple of questions, is simply just sketch the graph. And I think they give you a graph with vectors, be able to pull those, turn them into the component form, and then do whatever math that's asked of you. And then you graph it just like a regular coordinate. The only difference is instead of this a point, we have a part of a ray, right? So we know rays infinitely go in one direction. So we have like a ray here, but it does stop at that point. So this would be the distance from the origin. So you draw it exactly like that. All right, looking at some more. Let's look at number 11. Number 11 says find the component form, which again, component form would basically just be this. So this is component form. And the magnitude, so the magnitude to be this again, of a vector v. They used v, I used u, same concept. Defined by the given points, assume the first point given is the initial point and the second point given is the terminal point. So the first thing to do is to find the component form. They want us to call it v. So to do that, oh, hold on. Let's write out those points. That would be -2, 4 and 3, 3. All right, so to find this component form of v, and you're given 2 points in space, meaning it doesn't start in the origin, You want to basically, I'll label it the best way that I know how, and I would say, let's call this coordinate x2 minus x1. You're basically finding the distance from x, and then this would be y2 minus y1. So I like to label them. So x1, y1, x2, y2. This is very specific here. I know like in college algebra, the order didn't really matter when you were trying to find the slope, but it does matter when you're trying to find the correct component form. They're telling us that this is the initial point. So we start here and we're heading there. So this would be the second point. So when we plug this in, it ends up being 3 minus negative 3 and then 3 minus 4. So therefore, two negatives make a positive. Oh, wait, that's a negative 2. Oh, negative 2. There you go. So two negatives make a positive. So 3 plus 2 gives you 5, and 3 minus 4 gives you negative 1. So therefore, this is the component form of V. So V would be 5 to negative 1. To give you a little better idea of what that means is 1, 2, 1, 2, 3, 4. This is where I started. 1, 2, 3. And this is where I went. So the component here means I went right 5 down 1. So you're finding the kind of like the displacement of your x and y value. And so you don't have to graph it on yours, but I just wanted so you could see how I just created that vector. So if I was to move this vector from the origin, it'd be the same thing as if I went over 5 down 1 as well. All right, so that's the first part, find the component form. The second part is find the magnitude. Oh, we're going to call it V. So to do this, this is the first term squared plus the second term squared. So basically it's going to be 5 squared plus negative 1 squared. Notice I put negative 1 in parentheses. Anytime you have a negative, always put it in parentheses so that you apply the squared to it as well. So 5 squared is 25, and negative 1 squared is 1. Then 25 plus 1 is 26. They do ask that you simplify if you can, but 26 only breaks down to 2 and 13, which can't go any further. So here is your magnitude of V. Remember, magnitude would be the distance. So the distance of this guy would be the square root of 26. Think of it like you're building a triangle, and you're trying to find the hypotenuse. Right? That's kind of the math that kind of goes around that. All right, so that's that. So let's look at another question. Let's look at number 12. Make sure we understand these concepts. You are given 1 comma 6 and 2 comma 3. So we start off with the component form, which will be the second term or second x. So that's 2 minus the first x, which is 1. Second y, so that's 3 minus the first y, which is 6. So 2 minus 1 gives me 1. 3 minus 6 gives me negative 3. So there you go. So there's your first component form. And then we just got to find the magnitude of that. So the magnitude of V would be the square root of 1 squared plus negative 3 squared. So in this case, that'd be 1 plus 9, which is the square root of 10. 10 breaks down to 2 and 5. So that's about as close or as far as you can go with the magnitude. All right. Let's look at another set of problems you'll be looking at. Let's look at number 27. 27 gives you the vector u as in the component form of 6, negative 3. You are asked, for part A, to find a unit vector pointing in the same direction. So what this means is 1, 2, 3, 4, 5, 6. 1, 2, 3. Call it u. A unit vector would be a vector that falls on the unit circle. So, but it has to go in the same direction. So I'm looking for a unit vector right here, this vector right here, that would go in the same direction, but would fall inside of a unit circle. So the way we do that is you first start off by finding its distance. What's its total distance here? So that's going to be the 6 squared plus negative 3 squared. In this case, that's 36 plus 9. which is 45. We can simplify this. This breaks down into 5 and 9. So that means it's the same thing as 9 times 5, which is the same thing as square root of 9 times the square root of 5, which then comes out to 3 square roots of 5. So this is what this is, and this is what it expects you to do. Now, what you do with this to actually get that unit vector, we're going to take, and this actually has a notation purposes. It doesn't show it in the book, but we've always done it like this as the unit vector of that vector. But it doesn't really highlight that anywhere in the book or explain that, in my opinion. But just for future notation, if you're looking at a different resource or anything like that, this is a unit vector. So now to find that, you take the original vector, 6 and -3, and you divide it by the magnitude. So I'm going to divide this by 3 square roots of 5 and 3 square roots of 5. So when I do that, 6 divided by 3 is 2. So now this becomes 2 over square root of 5. And then 3 goes into 3 one time. So that's -1 over square root of 5. When I was looking at y'all's homework, it did not rationalize it. It actually kept it like this. So that would be your unit vector. So this vector would be this guy right here. So it's in the same direction, but now it's going to fall within a unit circle. All right, so that's part A. Part B simply just says write the linear combination of I and J in the equivalency of U. So this basically is your I and this is your J. So the way we write this is you would say U is equal to 6I minus 3J. It's a minus sign because it's a negative. Had it been a positive, then it would be a plus J. But this would be its linear form, which is that same almost form of the A plus BI situation with a complex number. But this is a two-dimensional vector. We do have three-dimensional vectors. I don't think we get to that in pre-cal, but you'll definitely see it in calculus 3 if you make it that far. But it'd be IJK. K would be that three-dimensional vector. Just to give you like a little heads up there. But part B is super easy. Part A can be super easy as well. I just wanted to show you that whole process there. All right, the next type of question. The next type of questions you'll see is in the set of number 33. And it says, find the magnitude and the direction angle of vector V. So you're given V is equal to 5 times the cosine of 30 degrees I plus sine 30 degrees J. So when it's in this form, it is super easy to find the magnitude and the direction angle. So the direct magnitude of V is this guy right here. So whatever the number is in front of the parentheses here is your magnitude. So it's simply just 5. To find the theta, it's literally going to be what is in the trig function. So your direction angle here, or theta, would be 30 degrees. So those would be your answers. So basically these type of questions in the homework is, do you know how to read a directional form in trig form? Are you able to analyze the two? So let's look at another one. Just in case you didn't follow that one. Let's look at number 34. V is equal to 7 cosine of 45 degrees I plus sine 45 degrees J. So again, my magnitude of V would be 7. And my theta is 45 degrees. And there you go. You don't have to convert it into radians or anything like that. Let's look at another one, because again, they ask a lot of these questions on your homework. So let's look at number 35. 35 says V is equal to 4I plus 3J. Now, we can't just pull our answers here. So what we have to do is to find the magnitude, is to say, all right, well, this is going to be the square root of 4 squared plus 3 squared. The reason I can do this, because remember, in component form, this is just 4 comma 3, which is now my V1 and V2. So now this is going to be 16 plus 9 which is actually 25, which is actually equal to 5. So now to find my theta, it's going to be the tan inverse of, instead of b over a, this time I guess it'll be v1, 2 over v1. So look at this one, this will be tan inverse of 3 over 4. And so again, we would just jump to the calculator. Again, hopefully at this point you understand how that works. We've done that many times, but you would just go trig, tan inverse. I like to do control divide to make it a fraction, and then I'll do 3 over 4. Ooh, 4. On your homework, I believe, let's see, they keep it in degrees, I believe. Let me make sure I wrote a note somewhere. Yep. They keep it in degrees. So make sure your calculator is now in degree mode. I think last lesson we were in radians. So this would be about 36.87 degrees, depending on what they want. All right, let's do another one to make sure you understood that. So let's look at number 36. This one is V equals negative 2I minus 2J. One thing to also note there, I didn't point it out, but we got to also make sure we know where we're at. So 4 comma 3 is, in this quadrant. So I don't have to do anything to that answer. I get my answer. But when we look at this one here, magnitude, nothing will change. Still going to be the square root of negative 2 squared plus negative 2 squared. So this will be 4 plus 4, which is square root of 8. 8's the same thing as 2 times 4. So that means square root of 4 times square root of 2, which now becomes 2 square roots of 2. So there's your magnitude there. They do expect you to be able to simplify that. All right, now when we look at theta, this would be tan inverse of b over, or v2 over v1. So that's negative 2 over negative 2. When you type that in your calculator, you get 45. Right? The issue with this answer is negative 2 falls in this category. So if I land it here and I need to go here, I need to add another 180 degrees to make sure I'm in the correct quadrant. So I'll then take 45, add 180 to it, and the correct answer for this situation will be 225 degrees. So even though you get 45 in the calculator, because this is negative 2 comma negative 2, we got to make sure we're in the correct quadrant. Alrighty. Another type of question I saw was number 43. Number 43, that set of questions there says, find the component form of V given its magnitude and angle it makes with the positive x-axis. So here we go. So you were given V, or the magnitude of V is 4. And in this one, you're actually told that V is in the direction of 2J plus, oh, my bad, 2I plus 3J. This is not your V. This is just, it happens to be in the same direction of this guy. So you can think of this in college algebra when we used to have to like find an equation that's parallel or perpendicular to this line. This is the same kind of concept. Whatever this angle is here will be the same angle of the answer I'm looking for. So to work through this, I need to find the angle. I already have my magnitude. So to find the angle, this would be tan inverse of 3 over 2. And this would give me 56.3 degrees. And in this situation, it's in the correct quadrant because 2 comma 3 is in this direction. So I don't have to do anything to this unit or this degree, so it's good to go. Now to get this, to find the correct component form that I want, I have to start off by stating that this is going to be the magnitude of V times the cosine of theta I plus the sine of theta j. So now I'm going to plug in what I know. This is 4 times cosine of 56.3 I plus sine of 56.3 J. So what I'm going to do is I'm going to apply the 4 to both of these. So this is 4 cosine of 56.3 I plus 4 sine of 56.3 J. Oh, and they got real specific here. All right, so because you're given this information, this 3, 2 here, they actually do expect you to form a triangle with that information. So tangent is opposite over adjacent. Now we got to find the hypotenuse here. So that would be a square root of 3 squared plus 2 squared. So that's 9 plus 4, so that's square root of 13. So this would have been just fine like this, but because you're given so much information, you can actually go a little bit further with this. So then cosine of 56.3, rather than plug it in straight to the calculator, we can use this triangle. So now you're actually given, so cosine is adjacent over hypotenuse. So that's going to be 2 over, I don't know why, but that parentheses, hold on. So this would be, oh, I did it like this. All right, so then 2 over the square root of 13, I plus 4 times sine is opposite over hypotenuse, so that'd be 3 over the square root of 13, j. And now this gives me 8 square root of 13 I plus 12 over the square root of 13 j. And then after this, they don't expect you to rationalize it, which I think is pretty nice. We just got to write this in component form. So component form would be 8 over square root of 13, comma, 12 over the square root of 13. All right, so usually we can just type this in the calculator, get our decimals, move on, but they do take the fact that you're given this much information. You can actually calculate what the actual answer is rather than a estimate. They claim that you have enough information to do that, which you do. It just makes a lot more work for you. All right, last couple of questions are, of course, our word problems. So number 46 says a golf ball is driven into the air at a speed of 75 miles per hour. So your rates, that's like your magnitude, right? Because it gives you direction and it also gives you distance. So 75 miles per hour ends up being your magnitude. And then it says, and at an angle of 50 degrees. So it gives you the angle of 50 degrees. From the horizontal, express the velocity in vector form. So all you got to do is the same concept as what we did this time, but we don't have enough information to have to use the triangle. So this time we can plug it into the calculator. So this will just be 75 times cosine of 50 degrees I plus cosine of 50 degree, oh, not cosine, sine of 50 degrees J. Then we distribute. So now I get 75 cosine of 50 degrees I plus 75 times sine of 50 degrees J. And then I'm just going to type that straight into the calculator so I can get my component forms here. So I come over here, that's going to be 75 times trig cosine 50. Again, make sure your calculator's in degrees. And you come out to about 48.21 I plus 75 times sine of 50. And this one gives me 57.45 J. So our component form here would just be 48.21 comma 57.45. All right. So that's how you do those type of problems. And then the last question here will be number 49. Number 49 says Prometheus is slowly pushing a 1,235 pound boulder across a flat plane with a force of 150 pounds, what is the total force being applied to the boulder? So when we think of this total force here as a component, your x-axis, right? That's what you're pushing it. You're pushing at 150 pounds. Now, what's being forced against you would be this 1,235 pounds. So since you're pushing this boulder at 150, this is a positive force, and then you are pushing a boulder that's giving you 1,235 pounds back at you. So this is a component form. So this is the force given, and this is the force basically coming back at you. So you're pushing at 150, 1,235 is coming back at you, but you're still trying to push at a horizontal plane. And then the second part of this question is simply saying, what is the magnitude of this force? So that would just be the square root of 150 squared plus negative 1,235 squared. And I'm just going to plug this straight into the calculator. So I'll do control x squared, and I'll do 150 squared plus negative 1235 in parentheses squared, and I get approximately 1,244.08. So that would be your magnitude there. And then that, of course, the units, because this is a word problem, would be pounds, or LB for short. And that's pretty much all you have when it comes to talking about the vectors in a Cartesian plane. As always, if you ever need more help or more examples, please reach out. I don't mind helping out with more. Other than that, I'll see you in the next video.